Okay, I'm going to talk a little bit about the hypothesis testing and the underlying theory on this. If you look at this, I got a normal curve here. I pulled this out of the reading. And if you remember, the area under the curve is equal to 100% or 1.00. So I don't remember this. Maybe trip takes an average of 35 hours. So what's the odds of me getting, say, more than 40? This is a one-tailed test. So I'm saying, well, I'm willing to put up with a 5% chance I get it wrong. So we run this test statistic, and basically come up with a critical value. If that critical value falls greater than, in this area, the 5% area, we then reject the null hypothesis. If it falls in here, we fail to reject the null hypothesis. Or said there's just not enough evidence to prove that it was just a random variation. So, or that it's not random variation. If I got a less than, in this case, I think they were talking about vitamins. What's the average is 20% of your daily allowances in each bowl of cereal or something. So I run the test statistic, and if it falls in here, I reject the null hypothesis. If it falls in this area, I fail to reject the null hypothesis. And if I got a 2%, or if I got a two-tailed test, I take that 5%, I divide it in half. So there's 2.5% over here, 2.5% over here. And it just so happens that the standard deviation is 1.96 standard deviations from the average above and below. So I run the statistic. If it falls in here, I reject the null. If it falls in here, I reject the null. If it falls in here, I fail to reject the null hypothesis. And that's it for hypothesis testing.